Welcome back everyone to this series of lecture videos that we're going to be calling useful methods. And in part one, we'll be diving into the apply methods available in Pandas. So in general, we now understand the very basics of grabbing and filtering data from either a series or a data frame in Pandas. And now what we're going to be doing is covering a wide variety of method calls available in Pandas. So data frames and series have these specialized method calls, and a lot of them are super useful and you should know them. But there's enough of them that we're actually going to make this a series of lectures in order to divide it out into reasonable timeframes and topics. And as a quick note, for your convenience, the lecture notebook for this series of lectures has a list at the top with links that take you directly to the relevant section of the notebook for any particular topic. So while this will be multiple videos, it's actually all referring to the same notebook called Useful Methods. And when we hop over to Jupyter Notebooks, I'll quickly explore that notebook with you to explain what I mean by this list of the links. So the very first useful method we're going to be covering, I think, is actually the most useful of all the useful methods, and it's the apply method call. And again, the way conditional filtering really levels up your skills with Pandas, understanding the apply method call correctly is going to give you yet another boost in your Pandas skills. And really what it does is it allows you to apply any custom Python function of your own to every row in a series. So we can use either one or multiple columns as input. Let's explore this in a brand new notebook, and I really think you're going to be impressed by Pandas capabilities here. Let's head to a Jupyter Notebook now. Okay, here I am in a brand new Jupyter Notebook. I've imported Pandas as PD and NumPy as NP, and then I also read in the tips.csv file that we've been working with, and here I have the head of that CSV file. Something I want to note real quick is the actual useful methods notebook that goes along with this. So I mentioned that there's a little list here at the top of the notebook. So this is the lecture notebook that we're going to be going through this series of lecture videos. And if you look up here at the top, there's two main links I want to explore with you. Let me zoom in just a little bit so you can see this better. So at the very top, there's a link to the documentation. So if you click that link, it's a really nice API reference, and if you go here to the left-hand tab, you can begin to easily start exploring things about a data frame, index, shape, etc. So lots of these things we've already covered, and we will be covering throughout this course, but I just want to let you know there's a great API reference available if you need it in the documentation. The second feature of this notebook that I really want you to be aware of is you'll notice there's a list of links here, and if you click on any of these links, it will actually take you and scroll down automatically in this lecture notebook for you to the relevant topic. So if we scroll back up here and you're at the useful methods notebook and you say, oh, I want to know about the replace method, just click here on replace, and it will scroll down to replace where it shows you the example that we're going to be explaining in this lecture video series. So just wanted to let you know that this is a very useful notebook that can serve as a reference for you. But let's head back, and I mentioned that the apply method is probably one of the most useful things to know when you begin to become skilled with Pandas. So we have here a DF head, and we have this data frame. And let's imagine that I wanted to, for whatever reason, grab the last 4 digits of this credit card number. Well, something I could do is I could try to say df dot and then hit tab here and explore the list of methods and see if there was something available to me that would maybe try to grab the last n number of digits in a string of some sort. But if we click on df info, you'll notice that one of the issues we have here with this credit card number is that it's an integer. So it's actually not an object or a string. And because it's an integer, that means that number is going to be in the format something like this. And if you're familiar with Python, you know you can't actually index like the last 4 digits of an integer. So if I try to say index at 0, it's going to say, hey, this integer object is not subscriptable, meaning you can't actually index it. So the first thing I would need to do is cast it to a string, run that, and then I can begin to grab indexed items, which means if I wanted the last 4 digits, I could use slice notation, and I could say -4 colon, which means starting at -4, or 4 from the very end, colon, go all the way to the end of this string. So this should grab me the last numbers, 5, 6, 3, 4, and if we run this, we see that's the case. Again, this is slice notation. It's standard in Python, works on a list, on a string, and the negative sign basically means just start at the end, go back 4 index positions, and then colon go all the way back to the end of the string. So grab starting at -4 all the way to the end of the string. So essentially, there's no real built-in method in Pandas that is going to be able to both convert to a string and then do this sort of exact slice notation. I could maybe stack multiple Pandas methods in order to figure this out, but eventually you're going to be coming upon a situation that Pandas does not have a built-in method for. And this is where the apply method comes in. It allows you to create a custom function and then apply it to a series in Pandas. So let's go ahead and functionalize this method. Essentially, just take this operation and put it inside of a function. So I will create my own custom function, and it's called last4. And it takes in the number, and what we're going to do is we're going to be taking in each of these numbers row by row. So we're going to say take in that number, colon, and then I want to return the string version of that number, but I only want to return 4 colon. And if I wanted to, I could kind of wrap this around an integer again to return it back as an integer. But we'll go ahead and just return it back as a string for simplicity. But what I'm doing here is I'm accepting some number, converting it to a string, so then I can index the last 4 digits. And obviously, this is not going to be some built-in method that's available right out of the box with Pandas. So let's go ahead and quickly check that this works like I expect it to. We'll say last4, 1, 2, 3, 4, 5, 6, 7, 8, 9. I run this, and it returns the string 6, 7, 8, 9. Perfect. So now what I want to do is apply last4 to every single row in the CC number row, which are all these integers. And the way we do this is we say df, you go ahead and grab the column you're referring to, the credit card number column, and then you say apply, and then you pass in the function you want to apply. In this case, it's last4. Something to note here is I'm just going to pass in the function itself. I am not going to actually execute or call the function. The reason for that is because Pandas will be doing that for us. It says, go ahead and grab this function and then start applying it yourself to every single row here. So if I just run this, you'll notice now I get back those last 4 digits of all those credit card numbers, and I'm getting them back as a string. And if for some reason I wanted to save this, because this is a series, I could easily make a new column called something like last4 and set it equal to this resulting series. The main idea here being that I just create my custom function, it takes in some number, and then I check to make sure it's working, and then I apply that to the credit card number. Something to keep in mind is that you have to make sure that the data type you expect is actually the data type that is in the actual Pandas data frame. So an easy mistake here would be to think that it's a string and then you try to right off the bat start indexing or slicing it when really you had to convert it to a string first. But hopefully you can see now this is a very powerful tool that allows you to easily apply your own custom function to any series here and then get back this result. So let's go ahead and do it with a slightly more complex function. Let's go ahead and check out the total bill column. So I have this total bill column, and maybe I'm working for a review site like Google Reviews or Yelp. And if you've ever gone to a review site like that, you'll notice that for how pricey a restaurant is, they usually report back if it's a $, $2 signs, or $3 signs. Right now, we just have the total bill price. Let's go ahead and create a custom function that takes in a single price and then returns either a single $, $2 signs, or $3 signs based off that price. So what is this going to look like? Let's actually first calculate the mean of this column. So I can say .mean, run that, and I can see the mean price for a total bill is $19.78, more or less. So we will call this function Yelp. It takes in some price, and the price is going to be every single row in this total bill column. And I'll say if the price is less than $10, then go ahead and return a single $. And then I can begin to stack this with elif statements. So I can say elif the price is greater than or equal to $10 and the price is less than $30. Essentially, if the price is between $10 and $30, we'll say return $2 signs. And then finally, we'll say else, meaning the price is actually greater than $30. Go ahead and return $3 signs. So you can see how we're actually able to then cut up a essentially continuous feature from 0 to n amount of dollars into what is essentially now a categorical feature, just 3 categories: single dollar sign, $2 signs, or $3 signs. So this is a slightly more complex function, but this is really just to show you that you have a lot of options here as far as the complexity of what your functions are able to do. And then I can say df Yelp is equal to df of the total bill. I apply Yelp. Again, I just pass in the function itself. I don't actually call it. We run that. And now if you check out, let's go ahead and check out Yelp here. In this new data frame, you'll notice it has those dollar signs. And if we check out the actual entire data frame, you'll notice it has 13 columns now, go all the way to the end, and we have those columns that we created. We have that last 4 column and then the Yelp column. Now, before we finish off this lecture, something I want to point out here is often once I show someone how to use the apply function, as we've just learned here, they immediately ask, well, now I want to create a custom function, but I want it to work off more than just one column value. So far, we've only shown you how to take in a single column value, like just the values in total bill column or the values in just the credit card number column. Next, what we want to learn about is what if I have a function that is dependent on 2 columns? For example, maybe I wanted some function to start working with the idea of a tip percentage. Well, something I could do is create a new column called tip percentage, as we've done in the past, and use that column based off tip and total bill, create a new column, and then apply something to that new column. But what we're going to show you in the next lecture is that these custom functions using the apply method can actually operate based off multiple inputs, not just 2 columns, but essentially however many columns you want. And what we need to talk about first is the lambda expression that it's going to use in order to actually run these custom functions based off the inputs of multiple columns. And then later on in the next lecture, we'll also talk about NP vectorize, which is going to be a way to make your applied functions perform much, much faster. Okay, so lots of exciting stuff coming up. The last thing I want to point out here, which is also a common beginner mistake when they're first using apply methods, is that these apply functions should only return a single value. Because when we think about what's actually happening here, is they're taking in a single value, which is the cell value for every row in this total bill column. And then what they should be returning is a single value, like a single string or a single integer, etc. What you should not be doing is returning some sort of entire series here. It should just be returning one single value because it's going to be a single value per row. So just keep that in mind. A common beginner mistake is they think that these apply functions need to return back an entire series, when really they should just be returning back a single value to be applied to every row in an entire series. Okay, so coming up next, we're going to take another leap off of this and show you how to apply a custom function to multiple columns. I'll see you there.